Welcome. We are going to start Terraform from today. Terraform is actually owned by HashiCorp, so it's called HashiCorp. Terraform is actually an infrastructure as a code tool that is extensively used in the wider IT landscape, and many people actually rely on Terraform for provisioning their infrastructure. When I say provisioning the infrastructure, it goes down from the VPC to the subnets to all the networking that we did in the earlier part. The servers, the load balancers, the network load balancers, the Route 53s, the RDS databases, everything and anything which is available in AWS can be created via Terraform as well. Terraform is just a wrapper, right? So it actually deals with the Amazon APIs, AWS APIs to create the resources. So it's an infrastructure as a code. What is infrastructure as a code in the first place? It is a way of defining and managing your infrastructure using code. So just like application code that sits right, the HTML files, the CSS, the JavaScript, AngularJS, PHP, whatever language the application has been written in, right? Like the application code, something similar we have for an infrastructure code. So rather than the manual process like clicking through the user interface or using the command line like we did yesterday, in the previous class, we did AWS S3 related commands. So those kind of stuff can also be done. So instead of doing or running all of these multiple commands to create the resources, you could have something called as a code base, which is organized in the form of folders and files inside it, which will help you create the sources. This means that you can manage your infrastructure in the same way that you manage your application code with version control, automation, collaboration. Other words, infrastructure as code is a way of making your infrastructure more like a software. Historically, right, infrastructure as code has seen many iterations, starting with configuration management tools like CF Engine, Chef, Puppet, Ansible, and Salt. So Ansible, which we will be discussing in the later part, will also be having also has AWS related modules which can be used to actually create resources. But we'll not be using Ansible because that is best for configuration management and not for infrastructure provisioning. What is configuration management? Let's say there is a server and you want to install HTTPD, the Apache web server, and then you want to place a HTML file inside the root, inside the var.html directory, right? For those kind of scenarios, Ansible would be better. Ansible is not best for creating infrastructure, right? Newer tools like CloudFormation and Terraform take a declarative approach and focus on the actual provisioning of the resources as opposed to the configuration of existing ones. The newest generation of tools focus on using the capabilities of existing imperative programming languages that are underlying the binary files. Now, CloudFormation and Terraform is what we can use. CloudFormation on one hand is only and only for AWS, right? So CloudFormation is an AWS service that gives you again an infrastructure as a code kind of feel, wherein you can write a certain code. Could be a description in a YAML file of what are the resources, what the type of resources and stuff like that. And if you run it, it will create that resource for you. So if you give a VPC code for CloudFormation, it's going to create the VPC for you, right? So that is CloudFormation. The only challenge is if you use CloudFormation, right? In future, if you want to migrate from AWS to Azure, or let's say you want to have a multi-cloud architecture wherein you also want to use Azure and GCP, in that case, it would be very, very, very difficult because CloudFormation is only and only agnostic to AWS. For Azure and GCP, you would have to think about something else. But if you learn either Terraform Terraform can be used across all the cloud providers and many more. Right. So Terraform is a tool for provisioning, managing, and deploying infrastructure resources. One, it is open source, written in Golang and created by HashiCorp, which is the company which owns it. Can manage infrastructure of your applications across multiple cloud providers like AWS, Azure, GCP, Alibaba, and many more. Right. So you have a lot of providers. So in Terraform terms, all of these cloud providers are actually called as providers in Terraform. So in Terraform, you have something called as a provider, which is going to provide you the uh, capabilities of creating the infrastructure. So you have GCP, Google Cloud Platform, Azure, Alibaba Cloud, Oracle Cloud Infrastructure, Kubernetes, AWS, you name it and you have it, right? It's not just these providers that are there. There are also many other providers that are out there. I will quickly give you a walkthrough of the providers. So Terraform providers. If you see, this is the major ones that are there in the bold, and then you have many other, right? So you have many providers that are available, which can be done. So if you see, there are 103 pages out of it which you can use. So some of them are official, some of them have been created by other people, uh, which if you want you can rely on. If you don't want, you can give it a skip. But there are multiple providers that are out there. Okay, so all of this is something which can be utilized to write and run our code. Now we will be focusing on the most used provider, that is AWS, and also this is a continuation of the entire course. Now we have already discussed the entire AWS part, so we will be discussing about how we can leverage Terraform to create those AWS services. Coming back, this is a list of providers. Now, what are the key features that we have in Terraform? Um, there are many steps generally which have to be followed when dealing with a tool or a new language, right? So the obvious one is, number one, you need to write some Terraform configuration, right? And that has to be saved in a certain file with a certain extension. We'll be discussing what those extensions and what those files are. So you will be writing some Terraform code. Then you would be initializing the directory. Now, directory is nothing but the folder in which you have written the code. You would be initializing that directory so that Terraform can start to make action, right? What Terraform init does is it will download the plugins into that directory. I'll actually show you what those plugins are, what those files are. It is actually going to download that plugin for you. That plugin is actually, or the files which are downloaded after that, right? The plugin is actually going to create the resources for you, right? In order to create a resource, you need to do a Terraform apply. If you want to see what resources are to be created, you can do a Terraform plan. A Terraform plan is going to give you an exact detail of the plan of execution or what resources Terraform wants to create on behalf of it. Now, if you're okay with the plan, you could do an apply, which I'll actually show you in detail. Right, we will be doing this in detail, so nothing to worry about that. Now, what are the extension files that we would be dealing with? There are many extensions apart from these, but this is the basic extensions that we will be doing. So the first is a .tf, that is a Terraform file. The other is a .tf vars, which is used to save variables. We'll be looking at variables probably in the third class from now. Then we have something called as tf state file. I'll be discussing what a state file is in detail in the coming slides. And these would be the basic ones. Out of these two, .tf state is something which Terraform creates for you. So you don't have to do anything with that. A .tf file and .tf vars file is written by you. right? You would have to write it out. What is a state file? So this is the most important reason why people choose Terraform. That is the state file, right? So what Terraform does is it keeps a track of the state of the resources it has created for you. Let's say you write in a code for Terraform to say that create a VPC for me. So you do a Terraform plan, so it will give you a plan. Then you say, okay, I like the plan, do a Terraform apply. So when you do a Terraform apply, then also it's going to give you a plan. You have to say yes, and then Terraform will create that thing for you. Now, what Terraform is going to do is it is going to remember all the details of that VPC that it has created for you, like the VPC ID, the VPC CIDR, all the settings in the VPC, everything and anything that you feel or you see on the AWS console for that VPC, that information would be saved in the state file. Now, the state file is more of a JSON format. You can either have it locally or you could have it in some remote location. We'll discuss what the remote location is afterwards, but that state file is somewhat created in your working tree. Now, the next time you make some changes, let's say you decide, no, I don't want the CIDR to be 10.18.0.0/16, but I want it to be 10.20 dot something dot something dot something. Then you just have to make your changes in the configuration file. Terraform is going to first check in the local state file and check on your code. Are the configurations matching? It will see that the configuration is not matching, and then it would initiate a change. Right. So that is when it will give you a plan that yeah, the actual configuration and this is way apart. I want to make it a change, and you can then make a change of the configuration. Right? That is how it works. We'll actually look at this practically, but this is what a state file is. And this is the only reason why people love Terraform, because it keeps a state file, right? So if something changed, you can actually go to the different versions of the state file and see what had actually changed or why something is not working, right? So that is something that can be done, and then it's very, very easy to replicate it back or revert it back, right? So that's about the state file. A remote state file. This section is of remote state file. We'll be discussing about that in the later section of the course. So this is where we are, and so this is how you need to start working with AWS providers. But in the meantime, what we can definitely do is go inside this, go inside CP, go batch number 38, and we can start writing our code over here. So I'll create a file called as terraform.aws, and let's actually create this file. So this is an empty directory that I have, right? And to start using AWS, right, what you need to do is in this empty directory or in this empty folder, I am actually using VS Code as my editor. And in this empty directory, what you need to do is create a file. So what is the file? The file could be of any name, any .tf, right? It should be with an extension of .tf, which is the Terraform file. Generally, we name that as main.tf. Understood? So just created a file called as main.tf, and now I can start using my Terraform to writing the code for AWS. But before I do that, I should make sure that I have access to AWS. Yes, I have access to AWS. Now, how did I get access to AWS? So what you need to do is you need to make sure that you have a user account, that is access key and a secret key. If you're not sure how that is done, let me quickly show you. You need to go to IAM in the AWS console. Go to IAM over here. And what we need to do is go to users. Where is users? You need to go to users. Under users, you have my user. Here, there is something called as security credentials, and I already have certain set security credentials. right? I cannot create another security credentials. I guess two credentials is a limit. So let's go to the other user and try to get a user. So my user security credentials would be 0. So I can create an access key. I'll call it as command line, blah blah blah. I'll say I understand. I click on next. You can give a description if you want. And this is a access key and a secret key that you will get. You need to download this file. Once you download that file, what you need to do is AWS configure. Now let's say AWS configure gives you an error that AWS is not found. Then you need to go ahead and install AWS CLI on your laptops. AWS CLI installation. If you are on Mac, follow the Mac instructions. So there is MacBook instructions. If you're Linux, you follow the Linux instructions. I was in Windows, so I followed the Windows instructions to get my AWS installed. Right, right. Once you do this, what you need to do is AWS configure. Here it is going to ask you for the secret key, the access key, the secret key, the region in which you want to operate, and that's it. Right. So make sure that you're doing all of this so that you are able to connect to your AWS account. How do you test if you're able to connect to the AWS account or not? Just do an AWS S3 LS and you would be able to connect to your AWS account. Or maybe test at least if you have access or not. If you don't have access, you will get credentials not found. If you have access, you'll get this. Now let's say you don't want to do all of this on your local laptop. Okay, very good. How can I do it in other ways? You could maybe create an EC2 instance, install Git on it, right? Do a yum install Git. You will get the GitHub installed on it, and then from there you could actually run your code, right? So that is another place where you can actually do your stuff. Okay, now that I have this code, right? I have this file system. What do I write inside that? How do I know what to write inside that, right? Okay, now that I have this code, right? I have this file system. What do I write inside that? How do I know what to write inside that, right? So that is where documentation comes in very, very, very handy. So let's actually go for the Terraform AWS documentation. I'm just typing this Terraform AWS documentation. Probably should give me the Terraform registry docs, blah, blah, blah. And here, the first thing that I need to do is on the extreme right, you have something called as use provider. So you need to copy this block, which is going to tell you how to use the provider, right? So this is the first thing that I do. I copy this and paste it over here, right? Oh, this is doing some beta thing. Okay, let's actually see. So if you see that was doing version 6.00 with beta. Now I don't want that. I want a stable version. So just change the version over here that is 5.98 and then you could use the same configuration over this, right? Now because we are actually learning, we will not like something to crash because we never know why it is crashing, right? So this is the provider. In the provider, what you could actually define is the region. So you here, if you see, there is also a documentation that they have provided, and they have also given you the first thing that you can create, which is a VPC. So let's see the region. I'll copy this and I'll paste it over here. So this is the region in which I want to create my resource. So this, right? I'll just save it, right? And let's actually do an init and see if it works or not. Now, do I have Terraform or not? Right, I have Terraform installed on my laptop already. Now, what if you don't have Terraform installed on your laptop? Excellent question. So go for Terraform download. Again, it will take you to documentation which will be cloud agnostic. If you're on Mac, you can follow these steps. If you are on Windows, download this and run it. If you are on Linux, you could follow either of these options, right? So this is how you could get Terraform installed on your laptop. Excellent. Any questions? Now that I have Terraform installed, what is the first command that we will do? We will be initializing the repository. Before I initialize the repository, let me show you how the repository looks like. I just increase the font. TF5, sorry, ls-la says that there is nothing. There's no dot files or anything. There's only one file called as main.tf, and if I do a cat to this main.tf, it says the provider is this and the region that I've set is this. That's it. Nothing else. So the first thing that I do is call it init. What init does is it will download the plugins. It is going to download the plugins from the internet onto your system. How does the download plugin look like? If you want to have a live view of it, this is how a dot folder is created. The license file comes in, and here's the provider file, right? So this is the actual file which is going to run your Terraform resources or create the resources for you. If you want to see initialization was successful, ls-la actually shows you this. If I do ls-la for this .terraform folder and again slash providers registry, so HashiCorp, AWS 5.98, I am on Windows. So this is the file that I have, ls-larh, and then this should give me the exact file in MB, that is 682 MB file. Oh god, I never knew this was this big. I The last I checked it was like 60 MB or something, right? So that is 2 years ago. But yeah, this is what we are dealing with. Okay, so this is how the initialization works. So what happens in initialization? This binary file is downloaded, nothing else. As of now, nothing else is happening. Now this is again a different file which Terraform has created. It's a Terraform block.hcl. You don't have to mess with it. Just leave it as it is. Nothing to be worried about it. Now coming back to the main.pf, what is the first thing that you would like to do? Let's say I want to create a VPC. Excellent. And even the Terraform documentation was saying create a VPC only, right? But I'm not going to use this block. What I'll do is I'll search for VPC on the extreme left, right? And maybe scroll down and try to find if you find AWS underscore VPC. So AWS underscore VPC is found, right? Now there are two things in Terraform. One is called as a resource, the other is called as a data block, right? The resource block is responsible for creating the resources on AWS. A data block is responsible for reading the resources. We'll be using the data block. Don't worry about that. But as of now, we are using the resource block. A resource block is used for reading the resources. Now, let's say you are working with GCP, right? Which I plan to work with. I've been doing some stuff with GCP also. So let's say I'm working with GCP. I also go with an N-1 version of it. And this is how so there is this thing called as documentation. In GCP, what is a VCP called as? I don't know. VPC service control. So let's see what is a VPC. Okay. What I definitely know is a storage. So that is called a bucket. So even in GCP, we have S3 buckets, right? So Google Storage Bucket is what we have. Now, if you see this Google Storage Bucket is a data source, right? So it starts with the data. That means it is not going to create the object for you, or it is not going to create the bucket for you. What it is going to do is it is just going to read it from the GCP console. But if you have the resource, that is this, it is going to create the bucket for you. So this is the code that is used to create a bucket in GCP. Now, can I put this code in my main.tf and will it work? No, it is not going to work. Why? Because the provider that I've selected is AWS. The provider which it is using is Google, right? The provider which it is using is Google. right? The provider is Google. If you see over here, this is the provider details. Understood? This is the provider. The provider is Google. That's why if I have a provider of AWS, I will not be able to create Google resources, right? Obviously, you need to make them separate by default. I'll close this Google stuff. You're not into that. So here, if you now notice, everything is AWS at the starting. That means it is using the AWS provider. That is the significance of it. Now there are two options that you have: copy the first block or copy the second block. Now, common sense says the second block is having more information, so probably this is better to be copied. So this I copy this, right? Now let's try to make sense of what this is. So when you're creating a VPC, what are the different things that you will need? You will need number one is the CIDR block, number one. Number two, you need to know the region in which you want to create it. That is the region we have defined it over here. And you need to give a name to the VPC. So I call it as my VPC01, right? I'll add another tag that is created by, and I'll call it as Terraform, right? And the CIDR block, let's say because this is batch number 38 for me, I'll call it as batch number 38. The 10.38.0.0/16 is what I have. Make sense? I hope so. Now, LSFNL. I already have the provider with me. The next thing that I need to do is Terraform plan. You hit enter and Terraform is going to do its magic. It is going to read your configuration, that is main.df, and it knows that okay, this person is requesting me to create a resource. The resource is AWS VPC. It is a VPC in AWS provider. It will see if the provider is mentioned or not. Yes, the provider is there. It's not just the provider, it should also be the required providers, right? So this is the actual provider that was there, right? The provider is matching. That means you are now able to create it. Now, what are the options that I have selected? The option that I have selected is CIDR block, which is visible over here. The option that I have selected is instance tenancy, which is default. If you remember, there are two, it's either default or dedicated. I'll go with this, and we have selected some tags. If you remember, when we did the RDS part, RDS was complaining that we should have DNS host names enabled, right? So if you want, you could enable this as well. How do you enable it? I don't know how to enable it. So AWS is going to give you some documentation around it. This is how it looks like. So enable DNS hostname. It's in the same page itself. We just have to scroll down or do a control F, and you will see it's an optional flag and it's a boolean flag. So what does a boolean flag mean? Either yes or no. So I'll call it this. What is that? I'll call it that equals to true, right? That's a boolean flag, and I've done that. Let's say I'll do a plan again. This time whatever I could remember, I have already added it to this, right? So whatever I could remember, options that are needed for creating an AWS account, AWS VPC have done that. So what I'll do is now I'll do a Terraform apply apply. If I do a Terraform apply, what is going to happen? It is again going to give me a plan. Let's try to understand what the plan is. Terraform, use the selected provider to generate the following execution plan. Resource actions indicate the following symbols. Plus indicates create, right? There could be some other options also, which we will be looking in the next run. In this, there's only create, so that's why we have a plus symbol, which is here. What is it creating? It's creating AWS VPC. How is it creating? So these are the options that it has provided. Everything looks okay to me. So what I'll do is say yes, and it will say that created equal to 1. It should say created equal to 1. So let's actually see if it even does that. Still creating is what it complains about. So let's go to VPC. And let's go into the right region, which is US East 1, and see what has happened. So apply completed, resources 1 added. So basically AWS says it added 1 resource. Now let's actually go into the AWS console and see if it even added the resource or is it just perfect. Luckily I see 2 VPCs, but both are with the same name. How do we know which one is which? There are 2 ways in which you can determine. Number 1, the CIDR range I kept it as 10.38.0.0/16, and the other one is tags. It says created by Terraform. Okay, this is how you can create your VPC. Let's say I'm done with the day, which I am, with today's class, and I want to delete the VPC that we just created using Terraform. All I have to do is say Terraform destroy, which is destroy, and it is going to destroy the VPC for me. So the VPC will be deleted. Obviously, it's going to give you a yes or a no question. But this time, if you see, it says minus, which is destroy, plus, which is create, minus, which is destroy. There is one more thing, which is change, which is actually an tilde. That is, I'll show you the simple once this condition is completed. The button which is below escape in your key. So this is tilde. So this symbol actually indicates changes, right? So we'll see what those changes are and stuff in the coming classes. But this is basically how you start writing your code in Terraform. All clear? Now there is this TF state file that gets created. Unfortunately, you don't have anything inside this TF state file. Why? Because you actually destroyed the stuff. If you want to have a look at it, very simple, just say Terraform apply. It will ask you for a yes or a no. Just say yes. Look at the state file. This should very soon change to version 5, and it is going to have some details about it. So let's wait for the creating to complete. Still creating, created, and this is how the thing works. So the serial is 5, and what it has done, it has created a resource. So resources, mode is managed, type is AWS VPC. This is the CIDR block. This is the ACL. This is the route table, the default route table, the default network ACL, the default security group. This is the VPC ID. Everything that you believe is needed for AWS VPC. That information is over here. In the coming class, that is tomorrow, we would, when I say tomorrow, whenever the next class is, so we would actually be looking at how to use this information from the state file to actually create other resources. When I mean other resources, it is the subnets, the route tables, and everything that we did to test our production environment. We'll try to do that same thing. So we'll be creating public subnet, private subnets, and all of that, right? So let's play around with that and try to get into a conclusion. Welcome back. Today we would be continuing discussion on Terraform. In the last class, we did write a simple code to create a VPC. Today we would be extending that to create the other features around the VPC. That is the subnets, the route tables, and everything. And along the way, we will try to understand some aspects of Terraform. So let me go into the folder where we have the code. So that is C, C, B, 4, LSF, CP hash number 38, LSF, and CD Terraform AWS. What I've done is I have integrated GitLab, that is my GitHub repository, to the folder that we were practicing yesterday, right? So I've already done that integration. Now the steps that I did for the integration are pretty basic. Number one, I created an SSH key pair. So do I get a history command? Oh, yes. So here if you see, I did SSH key pair. So I have created an SSH key and with this command. So this will allow you to create an SSH. This will allow you to create an SSH keeper. And once the SSH keeper is created, I did the renaming of the private key to .pem, and we added the public key, and then we added the public key to this profile where I have SSH keys in my AWS account for the GitLab account. I've added the key over here, and what I did is I created a SSH config file in my root account. So in my root folder, so that is .ssh config. So if you look at this file, so I have added a config file into my root, which is actually pointing to the configuration is host GitLab, user is Git, and the identity file is the file that I have been using. Now this might change a bit if you're using macOS or something else, but overall the idea remains the same. We should be able to authenticate with your GitLab for integrating it this with GitLab. I'll not be pushing any code as of now. This is just something which we did give it a try last week, but didn't work out. So just telling how it has been fixed. Okay. So let's actually see what all we have. So we have a main.tf. Let's open this in Visual Studio Code. So we have a main.tf with us, and that main.tf is actually having the provider block along with the along with some other stuff. So let's actually go and see. This is the provider block that we had, and this is the VPC part that we created. The next part that we are going to do is add the subnets to this entire thing. But what comes with the subnets is this. Like we already have the VPC created. So when we are creating the subnets, we have to make sure that we are creating the subnets inside this VPC. That means we will be taking in the details of this VPC and using it in the subnet block. So let's actually see how that is done. So if you have not bookmarked that thing, right? So you could say AWS subnet Terraform, and it should give you the documentation. So make sure that you go to the official Terraform documentation. This is the registry provider. Once you go to the registry provider, what you could do is go to documentation, which should be there on the extreme right. Make sure that we are using version 5.98. So where do we find the version? The version is somewhere here, right? So we are using 5.98. So always make sure that we are into that documentation. Go to the documentation piece, and here what you could do is search for AWS underscore subnet, right? Once you do this, you can scroll down a bit, and you definitely will see AWS subnet somewhere. Now, if you're not able to search like this, the other thing that you can do is subnet, and that should take us to the subnet page. So this is the resource block. That means it is going to create something for us, which is good. Now if you come down, here it is giving us the details. So this is the code block that it is asking us to copy. I'll copy this code block and we will paste it over this in our main.something file. So here if you see, the resource is AWS main VPC. Now this part, AWS underscore VPC and main, right? This main is an internal name that is provided in the Terraform block. So when I create the state, right? So okay, this is actually destroyed, so we don't have a state. So Terraform is actually going to save all the data that is called the metadata of this VPC under the name AWS VPC dot main, and that is how we are also calling the main function over here. So here, if you see AWS subnet, I'm calling this as The VPC ID is being referred to as AWS underscore VPC, which is this, and we are calling it as main.id. That is how we are calling it. Now here, this is going to fail because the CIDR blocks are entirely off. I need to do it as 10.38.0.0/24, and that is only when this is gonna work. Even a slash 1.0 is going to work, but I'll make it sure that it is starting from the zero header as well. Now the name I would call it as my subnet. Now because we already know the difference between a public subnet and a private subnet, I'll call it as my public subnet 1A, and I click on save. Now here I mentioned 1A, but I am not actually providing any of the availability zone details over here. What you can do is go to the documentation. There should be availability zone somewhere, right? So these are the two availability zones in the additional arguments that can be put in. And one of those additional arguments is, either availability zone or availability zone ID. Now it's totally up to you. So if you go to the document, the details, right? Easy is optional. Easy ID of the subnet. This argument is not supported in all regions or partitions. If necessary, use availability zone. So basically, what they're saying is, it's better to use availability zone instead of all of that. Okay, in that case, let's go ahead, copy availability zone and add that. Now here, if you see, Terraform is not difficult. The only way Terraform would be easy is if you know AWS in and out. If you are a bit shaky with AWS, then yes, Terraform would be difficult. I'm putting it as US East 1A. Let's actually see if this even works or it gives us any errors. So I'm already logged in, right? I'm able to access my AWS part. So this is my AWS S3, so it makes sense. What I'm going to do is say Terraform init and Terraform plan. So it is going to give you a plan of what it is going to create. We for sure know that it is going to create the VPC for us, and the next thing that it is going to create is the subnet. So let's actually say Terraform apply and see if it actually creates the stuff or not. It's asking me to enter yes or no, and it would only take the argument yes in lowercase, right? So make sure that you're not mistyping anything and stuff like that. If you mistype, it's not going to proceed further and crash. And you could recreate that stuff using the next time it asks yes, right? You could do that, so that should not be a. So let's go to the VPC and see what's the state of the VPC. I should be having the one new subnet being created. So let's go to subnets. Oh, here I see a lot of subnets over here, right? So let's actually get rid of our oldest VPC that we created during the CLI practice. Okay, it's not able to delete it. Why? Because it is available. So I have a Elastic Network Interface card which is in the available state. So I need to go ahead and clean up that first. Let's do that. ENIs is something which you will find in Elastic Network Interfaces. And yeah, I only have one. This is for the Elastic file system that we created. I'll delete this, not needed as of now. And if you now try to delete the VPC, it should delete the VPC for you. Make sure that the VPC is being deleted. So it should delete all the subnets, security groups, internet gateway, NAT gateway, and everything for you. Right? So as you delete the VPC, anything which is inside the VPC will be deleted. But let's say there are some EC2 instances that are running. Will they be deleted? No, that will not be deleted. Right. So here now, if you see, I would refresh the page. There is this subnet that we have created, right? The tags though I've not added the Terraform tag. We can add that. But what I'm interested to see is, has this come in the availability zone 1A or not, right? So as we see, it is in the availability zone 1A, which is excellent for us. Now for high availability, we will be going with two resources, right? I'll be going with two resources. So this time I will change this to 1B, and I'll call it as 1B again, and I'll call it as 1.0. If I do a Terraform apply, I'm not doing a plan straight away, but here if you see, if I do a Terraform plan or an apply, it is going to throw an error saying that a duplicate resource was found. What is a duplicate resource? Duplicate resource AWS subnet configuration. Line number 37 as a duplicate resource is basically what it's containing, right? Now, the reason it says duplicate resource is because the subnets are are having the same name in Terraforms, and Terraform will not be able to save it because here you see resource, AWS subnet, and the name is main. Now this name should be unique. It should not be the same for all the places. This is Terraform's internal way of handling stuff, right? So for that reason, what we will do is I will first destroy whatever we have. Obviously, we'll comment out this block. Let's destroy whatever we have, and let's come up with a proper naming convention. Again, going to ask me for yes or a no. Now that that's being destroyed, yeah, I'll call it as my VPC. This is my underscore pub underscore subnet underscore 1A. This block would be my public subnet. This is my underscore public subnet 1B. Right? Makes sense? This is what we have. Now we could have this created part over here as well. And this is fine. What is the next thing that gets created after the subnets? Internet gateway, right? So make sure you go to AWS. Maybe you can type internet gateway. I'm not 100% sure what it's called. Is it called IGW or internet gateway? It's called internet gateway. And here, if you see, this block is actually creating the internet gateway, and here it is asking you for the VPC ID. So I could punch in the VPC ID, and that should give me the IGW for my VPC. The good thing about this block is if you do the IGW part manually in AWS, right, you have to first create it and then associate the IGW with the VPC. This will do both the stuff together for you. IGW, and you can always go with that created part, which is this, and save it. Let's run this and see if Terraform apply. I'm not doing a plan again because Terraform would first give me a plan and then only will create the resource. So Terraform apply already is doing a plan, so I'm not repeating that. Now, what is the errors that we are getting? The error that we are getting is, say, complaining that line number 28, resource was not found. The resource, blah, blah, blah. It says that the managed VPC main has not been declared in the root module. Now that is because we actually changed the name of our module name, that is a resource name in Terraform, to something else. I've changed it to my.vpc, and for that reason, anything which says main.vpc, you would not be able to find it. So you need to change that to my underscore vpc dot id. Right? Make sure that you're doing that. And if you now do a Terraform apply, hopefully we should not be getting an error and we should be able to create the resource. Pretty simple. Okay. What's the next thing that gets created? I'll wait for this creation to be completed.
So along the way, I am trying to make you familiar with the errors that you would be getting with Terraform, because writing the code, copying it from the documentation is pretty simple. The only place where you would find it challenging is to understand how to integrate stuff. The next part that we are going to create is route table. So let's say RO route table. So again, I need to go to the VPC section of the course. So the route table is available in the VPC section. VPC resources AWS route table. So this is the route table that we create, and then there are something called as the routes which are added inside. So let's copy this block and put it inside this part. Hopefully it's making sense. The first thing that I'll do is copy this VPC part so that it doesn't complain that the VPC was not found. Now, so this is the route. So it's also creating routes for you. I don't want a IPv6 route, so I'll just remove that. What we want is actually a 0.0.0.0.0.0/0. I actually want the route to the internet via this. So that's why I would have to do with this. Internet gateway. So I already have an internet gateway with me. So I'll just copy paste this part and let's see if it actually creates the route table or not. So my pub underscore route underscore table, right? And let's see if it actually creates that or not. Are we missing anything? Yes, there could be many things that are missing, right? So let's see what it is. So here, if you see, it is refreshing the state. It found everything is already in place and it is now creating the route table for me. The route table has been created. So you could definitely go to your AWS console and see the route table was created properly. Just refresh the page so that the older ones are not visible. So this is the route table that was created and I have my internet gateway, that is this. Very simple. Nothing fancy about it. Now if you want to actually see if that internet gateway is yours, do a control F in your state file and you will find that the internet gateway belongs to you. Right? Pretty simple. Now what we have not done is subnet association for these route tables. So we need to associate the subnets for these route tables. Now I'm not going to do that manually, but we'll do that via code. So a route table association is something which is out there. All you have to do is do a route table association for your stuff. Again, very simple, nothing fancy about it, right? It's a route table subnet association, and I would change that as my underscore um my underscore puff route table 1A route table with subnet 1A, right? So I need to provide the subnet details. So that is my underscore subnet dot 1A dot ID. And the route table, unfortunately, we didn't change the route table's Terraform name, so we'll have to live with this. And what we can do is something like this, and also associate 1B with 1B. That's it. And save the changes. Run Terraform, and it should give you a list of again changes that are going to come in, and if there are no errors, it is going to create the decisions for you. Right? Chatting two things, what is it doing? It's going to associate, it's going to add subnet association. Very good. Subnet association done. You could come and review on your stuff wherein you are having the subnets associated with this block. Makes sense? The next thing that you create is NACL. So that is network. I guess ACL is what it's called. So network ACL is where you go, and here you could create your network access control. Yes, that is the main dot something or something. Come back. After this, we'll be creating our EC2 instance. So stay tuned is what I would say. Public underscore NACL. I'll copy the main block that is AWS VPC, that is my vpc.id. So egress is the outbound traffic, ingress is the inbound traffic. Make sure that you are aligned with it. So for egress, what I'm going to do is I'm going to allow the outer world connections to the ephemeral ports, that is 1024 to 65,535. Right. Now that this is done, what I'm also going to do is I am going to add another egress, rule number 200, and I am going to allow 443 to the outside world. This is to check if internet connectivity is there on the server or not. For ingress, what I am doing is, for ingress, what I'm going to do is I'm going to allow, the first thing that I'm going to allow is port number 22, and this is 0.0.0.0/0. And the second ingress that I am going to allow is ephemeral ports over here as well, just to see if it is working for us or not. So that is 1024 to 65,535. Yep, makes sense. Yes. Now what we can also do is allow port number 80 if you want to post a website and see if it's working for you or not. So let's also do that, and let's put this right. I call this route table as my underscore NACL as my public underscore NACL, right? This is done. Now along with the NACL, you also know that you need network access control list association. So make sure that you're also copying this piece of the code and then putting it over here. Now the network ACL, so you already will get it over here. So just do this. Now the reason I'm getting suggestions is because I have Terraform wrapper, that is a Terraform plugin for VS Code associated with me. So make sure that you are also using that. So you could go to plugins, extensions, and just install the Terraform extension for your. I have this Terraform installed. So once you have this installation, and then you would be getting these suggestions seamlessly. So this is pub NACL with sub 1A, right? And I need to do the association again for private subnet 1B. So that should be good. I believe everything is already in place. So let's do a Terraform apply and see if there are any errors that come in. If not, we should be happy. If they come, and we'll try to fix it. Right. So as of now, no errors. So if you don't type actual YES, then apply will be cancelled. So make sure that you are not in a hurry like me, and take your time to write and punch it out. So yes, yes, yes. Cool. So this is creating our stuff. So let's see. Okay. So what does it say? It's in the creating network ACL, EC2 network ACL, blah 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 entry, operation error, create network ACL entry. What network entry already exists? Network ACL entry. Maybe what has happened is because for the ingress I didn't change the rule numbers. Make sure that you are having the proper rule numbers in the ingress and then only try. Right, so that is the reason why it actually failed. Right, so this is the error that you could get in by creating network ACLs. Let's say yes, and it is going to create a network ACL for you. Very simple, right? No rocket science. Network ACLs, it should be having a public ACL and it should also have Just refresh this page. It should also have your two subnets associated. The inbound rule should be allowing three things. The outbound rule should be either allowing two things, and yes, it does. Right. Now, let's actually create an EC2 instance, that is a jump server or a website, and then see how it works. This is where, for the first time, we are going to use the data block. Right. So let's actually see how that is done. So EC2. So that is EC2. Let's see. So EC2 instance or AWS instance is what it is called. I don't want instances. I just want an AWS instance. And unfortunately, this is a data block. Now, what I want is a resource block. So let's close this out. AWS instance, and I hope that this is a resource block. A resource block is going to create the instance for you. A data block is going to read it from whatever place it is. Now, here if you see, we are actually using a data block, and that data block, so this is the data block, and this data block is to get the AMI details, that is the Amazon machine image AMI details of your AMI, right? So this is to get the AMI. Now, once you provide all of this, what is going to come out is the AMI ID, that is the ID of the AMI, right? So that is what you're going to get once you do all of this. Now, we'll not go with the standard example, but I want an Amazon Linux 2 AMI, right? So I'll go and search for that. So how do I search for the Amazon Linux 2 AMI? Obviously, this search thing will be different, right? So for that, what you could do is you could always argue that you would provide the AMI details hard coded. That is, you could actually give the ID itself, but it's not recommended because there's a new ID every now and then that AWS launches. It will have the best security patches and everything, right? So for that reason, it's always better to go with the search criteria. Now, searching it like this is very difficult in AWS. Searching it from more than thousands of VM is extremely difficult. So what I generally obviously do is copy the AMI ID from here, right? I copy the AMI ID from here. I go back to the EC2 dashboard. I go back to AMIs, search for this AMI over here, and this is the name of the AMI that I am going to use. Here, if you see, what these folks have done is they have hard coded the entire name. They have hard coded the entire name here itself. That is, there's no star that can be used in the Amazon Linux AMI because the date stamp is there in the middle, right? So I'll call like this, and this is what I have. So the virtualization type is HVM. You would find it somewhere there. So virtualization type is HVM, and the owners are someone else. So make sure that you change the owner. That's it, right? So once you have provided all of this information, what you're going to get is a data block. So let's actually do that and see if you're getting data block. That's not applying. Takes a lot of time. Okay. It applied the infrastructure, nothing was there. So let's actually go and see if there is. Copy this and see in the state file if you have something. Yeah, we have this. And what is the AMI ID? The AMI ID comes out to be this, right? So this is the AMI that it has taken. This is the data block. It's not going to apply anything. So that's why you didn't see any uptime happened. So this is what we have. This is my web server. So what is my web underscore server. And instead of this, I have Amazon Linux dot ID is what I'm going to use. I'm going with a T3 micro, which is fine. There are many other things that are needed, right? So the next thing that we would need is a key name. That is, you need a key pair to log into your EC2 instance, authenticate, right? So let's find where the key pair is. There are a lot of other examples which you can definitely give it a read through, but I am most probably sure of what I want, so I would likely be going into that place. If you're not able to find it like this, just do a control F and that should take you to the action place. So this is the key pair that is needed, that is the key name is needed. So it's key underscore name, and you need to provide the name with which you are going to give. Now we already have a key pair. I'm not going to create a new key pair for this system, but using Terraform, you can also create a key pair for yourself, right? I'm going with this my key pair in USB East one, so I will call this as this. This is the key pair with which my EC2 instance will be created. What is the other thing that we need? Because I'm calling it as my web server, so I actually need a security group along with this to be created. So let's actually go ahead and look for security, security group. So AWS security group is what I can create. Make sure. Mhm. This is the block for the security group. It's a big block, is what I would say. Now I want the security group to be created before the VPC, uh, before the EC2 instance is created. So that's why what we can do is you can actually add a depends on tag. And what does it depends on? AWS underscore security group is what it will depend on. So this is allow TLS. I'll say allow SSH and HTTP. This is the security group that I'm going to create. So what depends does is this is a Terraform feature. What this does is it will not create the AWS instance until and unless the security group is created, and the security group will be created in this block over here. So I'll call this as my.vpc.id. You could change the names. There's nothing fancy or wrong with the names. HTTP allows TCP, HTTP, and SSH inbound traffic and all outbound traffic. I'll call it as again the name. So you could call it as my underscore SG for SSH underscore HTTP, right? So this is the rules, and here we are creating the here we are going to create these, right? So make sure that you are changing the thing on all the places and not just only one place. I don't want an IPv6, so I'm going to get rid of this. So this is the outbound rule, that is the egress, right? So make sure that you're not doing anything with the egress. It should always be that. What I'm going to do is port number 80. I'm going to allow port number 80. But if you see, there's one thing which is missing. That is the source or the destination. In the security rule, oh, what we were missing is the CIDR range, right? Now, obviously, because this is a security group and this is inbound, right? So CIDR is where this rule is committed. Now, what I'm going to do is I'm going to change this to 0.0.0.0 slash 0, right? This has to be in double inverted commas because this is a string, and save it. Same thing here, I would be doing it on 0.0.0.0 slash 0. Now, in place of 0.0, you could actually provide your IP address also, but that still works for me at least. Now, once this is done, what I'll do is I'll provide the security groups, right? And the security group that I have is AWS underscore security group underscore dot, what is it? Allow something, allows a section dot ID, right? So this is something that I have, and I'll click on save. So once I do this, right, I'm still blocking this AWS instance part just to test if the security group thing is working or not. Terraform apply. Let's actually see if the Terraform, if the security group part is working. Okay, this is actually giving me an error. Why? Because there is IPv6 somewhere, and it is expecting IPv, and the output that I provided is IPv4. So let's actually do that. So this clearly said IPv6, and this method was clearly IPv4. So that's the reason it didn't work. So this is working. Security group should be created. It's not should not take a lot of time. Now let's actually uncomment our block of the code and see how it works. Terraform apply, and I'm going to apply with this stuff, right? Now let's see if it actually throws an error. Yes, uh, expected error. So why is it throwing an error? So the error is because here it says security groups. If you see there's an S at the end, that means it is a plural. That is it needs something more, right? And I only provided one security group. So whenever you see S at the name, right, it is expecting an array. It is expecting an array, right? And if you want to give something else, you can give it like this, right? So this could be your security group number two or something. Now we don't have a second security group, so that's why it is like this. If you give it another try, Terraform apply, it should give us some progress. Maybe it is going to create that thing for us. Yes, it wants to create. Now we don't know if it will create or not. Right? Okay. Okay. Creating an EC2 instance, run EC2 instance, blah 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 blah. Group name is only supported in EC2 classic and default security group. Right? What is that group name? VPC ID is not provided. So we didn't actually provide the VPC and other things, right? So let's actually see how that is defined. So how do I define a VPC? Excellent question. So let's control F VPC. It should either, okay, this is not here. I want to search it in AWS instance. Where is the instance? This is the instance. I need VPC to be defined over somewhere. So I would either provide VPC details or the subnet details, right? So VPC subnet ID, VPC security groups, non-default VPC. So here if you see, you also have to provide a non-default VPC. So if you are providing security group, then you need to provide this variable and not the security groups variable. The security groups variable is only going to work for the classic VPC, that is the default VPC. So this is also not going to work. And anyways, I need to provide the subnet ID, right? So let's go back to our dashboard. Here I say subnet ID and AWS underscore net. I'm going to put it in this subnet, which is good. And security groups should not be the same. Now I've done that. It's set to auto save, so it will automatically save my Terraform. The VS Code is set for an auto save. Make sure that you're saving the code before running every time. Do a control S, do a yes, and it should at least create the what? Try to create the thing for you, and might throw an error for security groups. So let's actually see if it throws the error for security groups or not. No, it didn't. It actually creates the EC2 instance, which is good. Let's see. Our EC2 instance, is it running or is it just just out there. Okay, the EC2 instance seems to be hello world, which is fine. If you see, I don't have a public IP assigned to this. We'll have to see why. And what I'm interested in is in security groups. So is it allowing my security group? Yes, it has allowed my security group. This is what I wanted. Now the problem is it's not having an IPv4 address. Why? Now with my experience, I know that I have missed something in the subnets itself. So when I created the subnets, so if you remember, there is an option for auto assign public IP. There is an auto assign public IP, and it's set to no, right? So we need to make sure that that is enabled on the subnet level. So the AWS underscore subnet again. So search for AWS subnets wherever that is. Not the data block, but the resource block. And here you need to check for auto assign 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 IPv6, no. Enable this, no. Map customer own, no. Map public IP on launch, right? So this is the option that I want. So copy this. Specify true to indicate the instance launched into the subnet should be associated with the public IP, and the default is false. So that is why it was false for us. Let's go back. Where is the security? Top somewhere in the above. So make sure that you are doing it as true, because this is a boolean character, so it will need that true or false statement to be assigned, and that is true, right? That's it. These are the two things that you needed, and you could create your thing. Now let's actually apply it. Perform apply. So what this is going to do is it is going to update our subnets for us. Is it going to recreate the EC2 instance? No, it's not going to recreate the EC2 instance, because all the configuration that we had provided for the EC2 instance remains the same, right? Or is it going to create the EC2 instance? Let's see. So it is also destroying something and recreating it, right? Will be replaced. So yes, it is also recreating the EC2 instance. Why is it recreating the EC2 instance? Let's actually see this. So here, if you see the security group, because of the security group, it is recreating the EC2 instance. I'll say it as yes, because anyways the EC2 instance is of no use for me. So I'll recreate the EC2 instance. But once the subnets are having that setting, right, and once we get a public IP, let's actually go to the EC2 instance and see is it even working or not, and then we'll try to run a Terraform apply again and see if the issue still occurs. What is the issue? The EC2 instance is getting recreated. Why is it getting recreated? It is getting recreated because of security groups. Now, did I change anything in the security groups? Absolutely no. Nothing has been changed in the security groups, but still this wants to recreate itself. So that's a bigger problem to address, and we'll try to address. We already know why that is happening, because I showed you the security group variable name that we had to take. That is the key value that we had to take or something else, and not this one, right? So that could be a possible reason. So obviously it takes some time for the instance to be destroyed, subnet to be modified, and a new instance to be created. AWS is going to take its own sweet time. Now, probably this is where we will pause for today after we test the EC2 instance and fix that part. In the next class, we would be looking into variables now, and we'll also try to see how we can simplify the code. Right. So let's actually see that. So coming to the EC2 instance, one of them should be terminated, the other one should be running. So let's actually see if that is true. Yes. And do I have a public IP? Yes, I have a public IP to my EC2 instance, which is even good. Now let's actually have another shell window. I'll go inside the directories, the keys, right, and let's SSH into that. SSH. That is ec2-user at the rate. This is the IP address, and this is my key pair. Blah blah blah. Linux being Linux, it will come up as soon as it can, right? So I'll do a yum update -y, and we'll also do wow, it's taking time. Not good. Yeah, completed. Yum install httpd, right? So yes, it has installed the httpd service. Systemctl enable httpd dot service. That is also done. cd var dub html echo. This is my website, and I want to put it into index.html. And then what I want to do is systemctl restart httpd dot service. Okay, makes sense. Let's actually see if we are able to access the website or not. Port number 80. Website should be working. This is my website, it's working. Excellent. Now let's test our theory that with Terraform applying and see if the Terraform is recreating our EC2 instance or not. Right? So here if you see, this time there is no subnet changes, but again it is going to delete and recreate the EC2 instance. Is this a good thing? Absolutely no. This is not a good thing to happen that your EC2 instance is getting recreated on every Terraform apply. The last time it was suitable because we wanted it to be recreated with a public IP. That's why we let it recreate. But in actual terms, we should not be doing that. So this security group part, right, is the reason why we should not be doing this. Associate security groups in a non-default PPC. So I actually need to use this instead of security groups if I want to have my PPC declared. So let's actually go here, and wherever you find this, make sure that you are changing it to this. Again, this is IDS, means IDs. That means it is looking for the array, right? I'll call it as no, and I'll go Terraform apply again. Hopefully, it is not going to ask us for recreation of EC2 instance. Even if it does, hopefully this should be the last time it asks us to recreate the EC2 instance. Oh, great. It's not asking us to recreate the EC2 instance. Make sense? Yes. So this is how you work with Terraform to actually create your EC2 instances or to create your setup or to create your entire infrastructure, right? So let's do a Terraform destroy, which is going to destroy all the resources that it has created so far. How many resources has it created so far? I'm not sure. So let's actually see what all it has created for us. So 15 resources were created. It is going to destroy all the 15 resources for us. I don't know what it did. Let's do a Terraform destroy again and see. Now let's say the next time you want to create, so it didn't destroy it. So yeah, I've destroyed it now. So destruction is now working properly. Let's say next time you want to create this setup, right? So this setup can be called as the production setup, wherein you have the jump server and everything set up. Obviously, you don't have the private subnets and the network NAT gateway and everything there, but you have this setup, right? Let's say I want to create this for a new batch. I'll call it as batch number 39. Hopefully you like the classes and recommend some folks to join me for the next batch, right? Let's say, right? And this is how it goes. And all I have to change is this IP address, that is 10.38 dot something, to I need to change it to 10.39. That's it. This is the only thing that will change. So I'll call it as 10.38 to 10.39. Just save it out. Right. So this one is still destroying. So let it destroy. But if you see the beauty of this, right, what is going to happen is I will be able to create my VPC, so, the entire setup for batch number 39 in like 10, in like 2 minutes or so, right? Because it's going to be very, 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 very fast. Why is it going to be fast? Because I already have the code. I just had to change certain places, certain variables, certain inputs at certain places, and I need to rerun that. So I'll go into batch number 39. I'll do a Terraform init. I'm directly doing a Terraform apply because it's going to give you a plan anyways. And if you run it, it should give you the details. It's going to give you the setup for that. Let's look at the VPC. I should not have any VPCs as of now because we terminated them. Hopefully, yes. So yes, I want to create 15 things for me, and that's it. It has started to create it. And here, if you see, it has now created the VPC for me. Very soon, you will see subnets being created. Very soon, you will see something else, a route table being created, and so on and so forth. Right? All the infrastructure that you wanted will be created in like minutes and not hours. It's definitely not going to take you an hour to create everything. It's only going to take you, let's say, less than 2 or 3 minutes to create the entire thing. Right. So this could be as big as an infrastructure. So this is how Terraform is very, 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 very important. Right. Now it is reducing the time it takes to create your infrastructure from, let's say, 1 week to set up everything. It is bringing it down to like minutes or hours. Right. In our case, from 1 hour of entire setup, it is now brought it down to this much, and along with EC2 instance. You could also have an AMI created in such a way that the EC2 instance also comes up properly. Right? You don't have to log in and do anything in EC2 instance. That is the level of setup that can be done. Right? But obviously, you're not going to venture into that. Terraform destroy is what you're going to do so that the resources are destroyed. Cleanup is excellent over here, right? So if you want to practice AWS, maybe start using Terraform as well. That is going to give you a better leverage of your time. You're not going to spend an hour creating the entire infrastructure. It will just take you a very little amount of time, like 2 minutes, to bring the entire VPC network and everything come up. And then probably you could practice your load balancers, DNS and stuff accordingly. Right. So this is what we have created for ourselves. Okay, we're also almost all an hour into it. The next class, right, what we're going to do is play with variables in Terraform, and we are also what we are going to do is reduce the size of this script, right? So if you see this thing, only for two subnets, one EC2 instance, and this, right? This is already at almost on a 207 lines, right? This is already this big. And we have not added private subnets, NACL, route table, private route table, private NACLs, right? So we have not added anything of that yet. If we keep on adding that, it would cross anywhere between, it will touch anywhere between 450 to 500 lines of code, which is very difficult for anyone new to go through. So tomorrow what we are going to do is we are going to refactor this code, right, into something else so that you get a better sense. So I'll rename this folder as 38-2, right? So this is one of the code. We'll continue using, or we'll create another folder and start using it, right? Great. That's it for today's class. Let's meet for the rest of the things tomorrow. So this is where we are. Let's continue our journey today. So what I'll do is I'll create a folder called as let's call it a new project or something. Uh, Client one. Okay, let's call it client one. What we will achieve with Terraform today is reducing the size of this code into smaller pieces so that it is well understood, right? Now, if you see this piece of code, right, it is only creating VPC to public subnets. It is attaching, it's creating a route table, it's creating an NACL, attaching that NACL and route table to the subnets, and then creating an EC2 instance. For the EC2 instance, we are also creating a security group that is allowing certain access, and that's mostly it, right? So this is what we are doing as of now. Now what we would like to achieve is reduce this 207 lines of code into smaller fractions so that it is easily understood by folks, right? So if anyone comes in and looks at the code, they should be easily be able to understand that. So what I'll do is the first piece of code that we see over here is that of the provider, right? So this is the provider block that we have. So what I'm going to do is create a file called as provider.tf, right? And what are we going to do with this provider.tf? I'm actually going to copy this and put it inside this, right? Very simple. So far so good. Now, what are we going to do? What is the next part of the code doing? It is actually creating our VPC, right? So for VPC, probably I'll call it as vpc.tf, okay? And I'll put the VPC code into this, okay? What I would also like to achieve is instead of repeating all the values or hard coding it in multiple files, right? These blocks, this information that is the CIDR range, the details, right? Now, editing in a single file is easy because you just have to change in all locations and that would do. But when it comes to multiple files, putting it in those locations is very difficult. So, what can we do? Uh, let's create another folder called as old or demo one. I just created a folder called as demo one, and what I am doing is I am putting all our files related to the first demo into that folder, right? So that the confusion is less. So this is how our stuff looks like now, right? So in the client one.tf, in the main.tf, so we have something of this. What we will be introducing is some variables. So I'll call it as variables.tf. Okay. And here we can define certain variable. So I'll define a variable. The variable name is VPC underscore CIDR underscore block, right? And if you want, you could define the variable here itself. That is, you could define the default value we get, or you could just declare the variable here and actually put the variable in a tf-vars file, right? So that is um, terraform.tfvars, terraform.tfvars, right? Terraform.tfvars is a variable file. So what is the variable that I want to define? VPC CIDR block. What is the CIDR block that I want to define? 10 dot, let's say it is 38.0.0 slash 16, right? Now that I have defined this, now that I have defined the variable and declared the value, how do I use it over here? It's very simple. You need to change this block to var.vpccidr block. That's it. We just have to change this to that, and this should work for you. In similar fashion, right, what you can do is you could also change the client name. So because this is client one, so let's declare another variable, calling it as client client name, and let's declare the value for client name, that is let's call it as ABC. Okay, the client name is ABC. Now what I want to do with this client name is, I instead of this my VPC, right, I want to have ABC hyphen blah 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 every time that comes in. So what am I going to do? So instead of this my, I will define the variable. Now how do I define this variable? Because this is inside double inverted commas, I need to do something like this: var dot, close the curly brackets, var dot client CLIE and underscore name. Okay, this is how I define it. Let's quickly see if that is still the same or not. Client name is this. So how is it going to look? It is going to say abc-vpc.com. Okay, vpc01. This is how it looks like. Now let's go ahead and create our subnets. Subnets dot tf. So we already have the block for creating subnets. I will just copy this piece of code and use this for my subnet. So where is my file? Subnets.tf. This is over this, right? So I already have, or I'm already referencing my VPC, right? So that is my VPC. Yeah, it is my VPC in subnets. So you have this variable now. So you can again define a variable called as subnet underscore CIDR underscore 1A, and you could define another one called as subnet underscore CIDR underscore 1B, right? And what you could do is go to subnets, and instead of using this block, you could call it as var dot subnet underscore CIDR 1A, and this will become var dot subnet CIDR 1B. Instead of my public subnet, so here you should be using this block, that is this piece, which is going to help you with that, right? So this is number one and this is number two. Yeah, and so this is how you could play around with stuff. So let's actually do the initialization and see if that even works. So let's actually do that. So I'm currently inside batch number 39, ls-l. So ours is batch number 38, ls-l. So we are inside the folder client one, and if I do this, I already have all of these files, which is good. We'll do a cat to all the star files. Everything will be in place. What I need to do is Terraform init first, because I don't have any Terraform binaries and plugins available with me. So what I need to do, I need to do an initialization first. And once the initialization is finished, we can do a Terraform plan and then an apply. Now, I being a bit lazy, what I do is I'll straight away do a Terraform apply, because Terraform apply will also give me a plan of what it wants to execute, right? So here if you see, it is not giving you this information. Okay, now here it is saying that I need to pass in a variable called as this subnet underscore CIDR underscore 1A. Why is that happening? Maybe because in Terraform vars have not entered these values, right? So make sure that you provide these values here /24. You need to also declare them. Subnet 1B would be 10.38.0.0. No. It should be 1.0/24, right? And cancel this again and again do a Terraform apply, and it should help you with the output. So it is planning to create three resources. The first one is a VPC, right? So it's creating a subnet 1A, subnet 1B, and then creating a VPC. So let's see if it actually creates the VPC or not. So it is now creating the VPC. In the meantime, what I'll do is log into the AWS console. Most probably it would have logged me out. And we are in the region this, so I should be able to see ABC VPC01, which has been created for me, and there should be two subnets ABC, blah 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 blah. Right. So this is how we can create multiple stuff. Now you would argue that this looks much better than this, right? Uh, but in future, right, what we are going to do is we are going to introduce something called as modules. Using modules, what would happen is you would be able to write code uh, in such a way that all you have to do is this initial part of the code you are going to write once, and then you are going to call that code multiple times for multiple clients, and then we are going to use it easily. Now this is how you can use variables. Now if you want, we can proceed further by creating an IGW route table and stuff like that, but the gist is it would still remain the same, right? So the entire process of creation remains the same. There's nothing that is going to change in terms of creation process, right? So everything else remains the same in this. Okay. So if you still want to play around, so what you could do is after subnets have been created, you could actually create a file for route table, and the entire route table association, everything can be kept in the same place. So let's actually do that. So I'll call it as igw.pf. Now IGW needs to be created, so I'll go with this, right? And the only thing is in the IGW, what I'm going to change is this part. So we are going to have this guy over here, the hyphen IGW. So the IGW is now being created. What you can do is create a route table.tf, and then you could have the entire route table. You can create the route table and also make sure that the subnet association of the route table happens in the same place. So maybe you could put both, right? So route table is here. With this, what happens is you don't have to search for your stuff, right? You know that the VPC section of the code is here. You know that the subnet section of the code is here. Route tables is here, and so on. So most of the stuff that you have, right, it would be with you only. Right? So that is the good thing about this part. I want to put in again this client name, and maybe have a hyphen instead of an underscore, right? So this is the route table that is being created. The IGW is being attached. The subnets are also being attached. Everything is in place. You could save it. If you want to do a Terraform apply, most probably it should not give us any errors. It should work out of the box, right? I'll say yes, and most probably it should not show any errors because the code is already tested yesterday, main.pf. We just are improving the code by putting it into legitimate boxes. That's it, right? So this is how you could keep on writing the code. Now I am not going to introduce new stuff over here. We are just going to leave it like this. I'm not going to keep on adding the other NACLs and stuff. Uh, it's already there. You could just reuse it, and that is going should be working fine. If there are any questions, do let us know, and we would try to address it in the next class. Okay. Right now, this is fine. let's say there are two people in the team who are working, right? And this is client one that I have, right? And suddenly what happens is I go on a vacation for the next 5 days and I am not available. And the client is very demanding. He says, no, 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 there should be some progress in the work. It cannot stop for 5 days, which is good, right? But what happens is the code is at my place. This code is with me. I have not given this code to my team member, right? So let's consider. I'll create another folder called as teammate. Let's consider this folder to be that my teammates folder, right? So that is on his laptop. This is the folder that we have. What I can do is let's close this window. This is the code that I have, just to reduce the confusion, right? So I've just minimized the code. This is the actual code that we have, which is good. So this is creating a VPC, and all the VPC and everything is already stored, right? It's not that the VPC and everything is not there; it's already stored. So what I will do is, what I'm going to do is, I would be actually now, because I'm going on a vacation, right? So I know that my teammate will need the Terraform code to actually build on top of the work, right? So what I do is I actually provide him some pieces of the code. When I mean some pieces of the code, I actually give him all the files that are needed for Terraform to function, right? So what I do, I actually give him a bookmark or a zip file, and that person what he does is he copies everything into his own folder structure. Okay, so this is my teammates folder structure. Everything looks new, right? So if you see the vpc.tf is there, yes. Are the variables declared? Yes. Have the Terraform wars been added? Yes. Subnet is there? Yes. Route table is there? Yes. Providers? Yes. IGW? Yes. Everything is there. So what this person has to do is, let's say he has to create an NaCl code, NaCl.tf. Now what he needs to do is he needs to create an NaCl code. So what this person will do is he will try to look at the internet to get network access control list. So that is network underscore ACL. Now I'm not referring the old code. Let's actually do it from scratch. So this is the thing that is here, and I'll copy paste it over here. Now from the subnets, what we know is VPC has to be called like this. So I'll call the VPC in this fashion. Make sense? Yes. So egress, what is this person doing? So egress roll number, let's say 100, he's allowing. Let's say I need to do it for 0.0.0.0 slash 0. I need to allow ephemeral ports to the entire world. That is 1024 to 65,535. 65,535. Right? And in the ingress, what I'm doing is I'm allowing port number 22 so that people can SSH into my thing. That is 0.0.0. There are already some zeros, so let's use that. Okay, looks good. The name is obviously different, so let's go with the variable. Ba, 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 right? And I'll call it as pub NaCl for public, right? Excellent, looks good. So I'm very happy as the teammate, right? The teammate is very happy that yes, he was able to add a piece of code and it looked legitimate. Okay. And what it does is he goes into his directory, which is cd ls cd batch number 38, Terraform cd. Okay. So this is the folder where he had, right? So what it does, he knows the steps. He went through a class on Terraform, and he knows that he needs to first do the initialization. So he first initializes the entire setup. Okay. And then what it does is he will do a Terraform apply so that it applies the NaCl piece of code, right? Legitimate. This is what we understood so far. Terraform app ly apply. If once he does the apply, right, he says okay 8 to add, and he says 0 to change and 0 to destroy. He's happy that there is nothing being destroyed, so he just says yes. And the moment he types yes, he realizes that there are 8 resources that are being created. That is where the first alarm is. Why is 8 resources being created? Because he just created one resource, that is NaCl. So we come and see, am I saying that we need to create 8 NaCls? No, it's not 8 NaCls. Now what's the problem? So let's see. Great. So let's continue today with Terraform, right? And so far in the last two classes of Terraform, we have seen how the Terraform configuration can be number one written in a single file, main.tf can be written in a single file, and then we yesterday saw how these files can be placed into multiple places, right? So this is the client one demo that we were doing, and we actually divided everything, all the stuff into different files, basically. Right. So this is where we stand. Now, what we would be doing is, so let me see what all it has. Today we'll continue by creating some DNS records, Route 53, and we'll also see databases. RDS. So while we are doing that, we will see for each loop in Route 53, and then we will see outputs, Terraform outputs in the ecosystem, right? So that's the basic idea. So we already have a VPC, which is good. We have subnets which are defined. We have a route table that is defined. IGW is there. So we don't have network ACL. So even if we don't create a network ACL of its own, that should be fine because AWS will be using its own ACL. That is the default ACL, which anyways is allowing all the traffic, right? So I guess network ACL is not going to cost us much. So this is what we have, and if you do a Terraform apply, which is going to give you a plan. Let's see what all resources it already has. Has it deleted, created resources or not? So it's already there. It just wants to delete one resource, and that is network ACL. Wow. Why did we create a network ACL? Where did we create a network ACL? So then the obvious question is, where is the block for the network ACL? Client one. Okay. So if you remember, so let's continue from the last class, right? So if you remember what has happened, my teammate that is inside this folder, right? I actually created a network ACL. NACL was created in this folder, but I don't have this configuration file with my. I don't have this configuration file with my client one directory, that is in my directory. So a teammate of mine actually created a network ACL. I don't have this configuration. Now when I did a Terraform apply, what is happening? Terraform says that, hey, I see there is a resource in the Terraform state file, which is this, but the configuration for this is not there in your directory. So I want to go ahead and delete this stuff. Right? This is what it is saying. There are two options. You could either go ahead and delete it, or what you can do is make sure that you have this piece of code with you, right? So it should be there within client one. This should be there. Now, if you try to do the Terraform apply, it is not going to give you this error saying that, hey, I want to delete stuff. No, that's not what happened. The rule is going to stay there as it is. Okay. Now let's actually modify these rules a bit so that I also have ingress on 5432, that is Postgres, right? And I'll make sure that the port the rule number is 200. I'm allowing the egress and I'm allowing this. So this should be fine. I'll do apply again. This should show some minor changes and it should actually allow us to update. Now, let's actually go ahead and see how to get your RDS up and running. So the code for RDS is AWS RDS Terraform. Don't go for modules. Make sure that you're always going for the resource block in Terraform, right? So this is the code that we have for your Postgres RDS. But if you see, this is actually an RDS cluster. So we don't want to use an RDS cluster, but I just want a database or DB instance to be connected. So let's actually see where the DB instance is. So if you're not getting it, you could always take help of any of the Gen AI tools, right? The Chat GPT or stuff like that. You will always ask them to create a rule for you, and that is going to help you out. Now, just to reduce the amount of effort that I have, what I have done is I already have a RDS code base from one of the previous batches. This is something which I am going to use as of now, right? Now let's actually see what this thing is doing. So number one, we are creating a subnet group. If you remember the RDS composition, the first thing that we have to do is make sure that you have a subnet group, allowing all the subnets that are there. Number two, here I'm creating a security group and we will be assigning that security group to this RDS, right? So let's actually go ahead and create a DB subnet group. So in order to create a DB subnet group, you could either copy this code base or you could get it from your documentation itself. So that is DB underscore subnet underscore group. So this is why does it say DB? No, it's a document DB subnet group. Yeah, I don't want a document DB subnet group. I just want a DB subnet group. So there are two different things, right? There's something called as a document DB which we don't need. What you need is a DB subnet group, which is this. And so make sure that you're copying the right part also. Now I'll be putting this in the rds.tf file. So everything that is mentioned here belongs to RDS. So I'll call it as my db rds underscore subnet underscore group. Right now, this is the main subnet group. You can name it anything. So that is my public subnet group, right? And in place of the databases, that is the subnet side. So you could say AWS underscore subnet underscore one dot IT, comma AWS underscore subnet one B dot IT, right? So this is how it works, and we already have this in place. So the next thing that we can do or we did over here is we actually created a security group. Now nothing new with the security group. We already have a security group code in the main.tf. When we created an EC2 instance, we actually did that. So I'm just allowing this and I call this, let's say, batch number 38, allow Postgres, blah, blah, blah. I need to change this VPC. So it is aws.vpc, my vpc.id, right? And so this is again b38.id, and that is also b38 postgres.id. So far so clear? So what we have done, we are creating a subnet group, then we are creating a security group, and these are the rules inside that security group. Nothing fancy about it. Only these things are there. Let's do a Terraform apply and let's see what happens actually. If you do a Terraform apply, you should be able to see that there are 3 additions or 4 additions to our existing infrastructure. So what's the first one? First one is a security group. Uh, First one is a subnet group, then there's a security group, and then we are creating 2 rules inside the security group. That's the only addition, nothing else. Right. Now let's actually get to the code where we are creating a database. So this is the code for creating a database, and I will paste it at the very end. If you see, I don't have this block. I would currently give a random password like this to the database, right? So this is the DB instance that is being created. What is the version of the DB instance? The DB instance version that we are creating is 16.2. Now we know that there is already a 17.1 of the Postgres DB instance. So let's go with that. I'll call this as batch number 38 PGDB Postgres. Everything else remains the same. The only thing that changes is the subnet group. So the subnet group I'll take from here, which is RDA subnet group, and we are going to replace it with this. Make sure it is asking for a name, it's not an ID, right? So make sure that we are following those small details. If not, anyways, you will get an error, but you need to be very sure with that. So this piece of code is going to create your database for you. And this database is going to be publicly accessible also, right? I hope that it is publicly accessible. Let's actually see. So I'm doing a Terraform apply and let's see what happens. So, yes, the database is being created. So I'll say yes. Let's actually go inside the database console and see what is happening. This is North Virginia region, and if I go to Aurora and RDS, did it throw an error? Yeah, it actually threw an error. So that's good. Okay, so creating a DB instance, blah blah blah, and what is it complaining that it doesn't has a DB parameter family group? Okay, let's go to parameter groups. I don't have a parameter group. Let's go with the default parameter group. The default parameter group is this. So let's actually see if I have that parameter group is, yeah. So here if you see the parameter group that was earlier there was of 16 because the version that I was using was 16, right? Unfortunately I changed that. So that's the reason why it actually broke. Let's also confirm the DB version. We'll quickly check that by selecting Postgres, and in the drop down I should be able to select the engine version. So there is 17.1 which is available, which is great. Let's go back. Let's do a Terraform apply. I've saved the code. This should not, hopefully not give an error. Now, so let's actually see what happens. I'll say yes, and it has now started creating it. So let's actually see if something has come up on the DB instance or not. Yeah. So Terraform creation is in progress. This is the initial part, right? So when the DB is actually created, that is when the name of the database might change. But this is what is happening. Now, what is the password that I would be using? to connect to the database, the password would be this person over here. Now, there's a small problem. The problem is you should not have these passwords in plain text over here, right? A password should never be in plain text. So, what is the alternative that I have? You could use something called as a random password generator or a random string generator in Terraform itself. That block is called as random password. So this is a different provider altogether. It's a random password provider. All you can do with this random password is if you just say this part, which is resource random password, you could call it as password, right? And you could define the number of special characters that you want to have and the length of the password if you want it to be 24 characters or if you want to be 64 characters. It's totally up to you. You could define the number of characters that you want in this thing to be available. And what this is going to do is this is going to create a random password for you, right? Now, this random password can be utilized in this place. How do you use it? Very simple. You just say random dot password. Hopefully that is what it says. And obviously you need to say dot results to use it. Dot results. Now, how do I know all of this? Excellent question. If you are thinking about it, I could go to the documentation again, random password, Terraform resource, right? So there is again this documentation page that would clearly tell you how to create a random password and how to use this password. So it is all documented. It's not that I'm inventing something. All you have to do is go to the documentation and read it, right? So this is the other way in which you could actually do the stuff. Makes sense? Has the DB application completed? It's still applying the database, so we'll have to wait for the database to be fully created. Only then we would be able to apply the new password that it is creating it. So far, this is the endpoint that has been created for us. It's configuring enhanced monitoring for us. Let's actually wait. In the meantime, you could see the database connections and everything that is already there. So nothing much happening. DB connections are zero as of now. So let's actually wait. See. So we'll have to wait for the entire thing to be set up. Now, the point is we are generating a random password here, which is good. We are using that random password over here. So with this generated password, database would be created, right? So the database would be updated or it would be created with this password, which is excellent. But my question is, how will we know what the password is? It's a fair point, right? So the password was automatically created over here, and the password would be automatically applied over here. It would not be displayed on the screen saying that this is the random thing that was generated and all of that. That is not going to happen with us, right? So the database completion completed. So let's actually see. DB is available. So this is the entry point. So let's go to PG admin. Anyone remembers what I typed as a password? Do I have it over here? Wow, I didn't save that. Anyways, I can do a control C to get that out. Yeah, this is the one. So let's copy this password. We need this password to connect to the database. So let's wait for PG admin to load up properly. This tool takes its own sweet time to actually come up. Okay. Let's actually register a new server. The name of the server is not the password, but this thing over here. I'll just remove all the backslash. Let's say that's the name of the password. Anyways, this is fine. Port number is fine. Postgres is the user. The database password is this. I click on save. And if our creation was successful, we would be able to connect to the database, right? So this is how we have connected to the database. It's working. Now what I want to do is I don't want to use this password, and I have been told that I need to change this, right? So this is what I'm going to do. We are going to create a random password, and with this random password, we are going to update this database password. Now what I want to do is I don't want to use this password, and I have been told that I need to change this, right? So this is what I'm going to do. We are going to create a random password, and with this random password, we are going to update this database password. Now I'll do a Terraform apply again, and let's see what happens. So basically, it is complaining that I don't have the module random password. So this is insufficient dependency log files probably. What it is asking me to do is run Terraform init hyphen hyphen just upgrade. Why? Because random, right? Random is a new thing that we have downloaded. It's a new provider. AWS is the existing provider that we have been using. Random is a new provider that we are using. So what we need to do is you need to say Terraform init hyphen upgrade with this. Once you do this, a new provider would be downloaded. I can show you the providers. So in .terraform, in providers, there are now two providers. Earlier was only AWS. Now you have a random provider, which is going to create a random password for you. And you can do a Terraform apply. And what this is going to do is give you the changes for the password. So number one, it is going to create a random password for you, and then it is going to change the password on the database. The good thing is, in order to change the password of the database, it is not going to recreate the database. It is just going to modify the database with immediate effect with the new password. So that is a better option that we have. So it's going to do this for us. So let's actually see the state of the database. It should be modifying, right? So it's resetting the master credentials is the state that it has went into. It should be completed very soon, and we should be able to log in with a new database. So I'll disconnect from this, and then we'll try to log in with a new password. Still modifying. Now you would be wondering, how does this person know what the password is, right? So for that, what we need to do is we need to export the variable. We need to export this random password, whatever was generated. This result has to be exported as an output variable, right? We have to define something called as an output.tf so that we can see what the password is. So you need to define something called as output.tf, and here you can actually get the password. How do you define the output? The output block is very simple. So this is the rds underscore eb underscore password. This is just a name that I'm giving, and the value is that is random password dot results. Most probably this. Now this is not going to work out of the box straight away. The reason being there are one or two additions that we'll have to do, which is this, right? So you need to tell AWS that this is a sensitive password. If you don't say this, this would actually print the output in the what do we call the output. So I'll let me just show you this. If I do a Terraform apply again, this is not going to change anything, but it is actually going to give us the output of the password. Okay. Output DB password to reduce the risk of accidental exposure of sensitive data, right? AWS has some generative AI with it, and this is what it says. You need to put sensitive equal to true at the end of this output dot Yes, because even Terraform believes that this is a password and it should not be visible to the outside world. Okay, I'll put this Terraform apply, and so this run should complete successfully without any changes, right? So it's asking me for a yes or a no. I say yes. Why? It is actually adding the DP password in a sensitive value and it's a sensitive value. Now, is this the password? The answer is no. That's not the password. How do we know what the password is then? Right? For this, do I have a history? History of web I output? No. Okay. What you need to do is retrieve the sensitive password. So Terraform output ret- retrieve sensitive data. Right. Output data has to copy equals instance. How to retrieve sensitive data, blah blah blah. Both of these are official documentations of Terraform. So what you need to do is you need to say Terraform output, Terraform output. If you just do this, it is going to say password is sensitive. What you need to again pass is I need I need this in the raw format. And what you need it in the raw format is this RDS password. So now hit enter. This should actually give you a passphrase or the password that it generated for you. So this is the password which will be saved in the database with which you can actually connect to the database. So I'll go over here, connections. Okay, let's double click. This is going to say that the password has please enter the correct password and stuff. And now you should be able to log into the password, right? So Terraform outputs is what we will be using extensively, right? So this is the command. Let me create a new. Let me create a new Terraform. I like it to be blank. So this is how you can extract the password, and I anyways would be providing you with the details of I anyways will be providing you with the code base, so you should be able to have that. So this is how you can extract the password details, right? You need to use the outputs so that you can export the thing first. Once it is exported out, then you can retrieve it using sensitive data. Now I could export multiple things, right? It's not just that the password has to be exported. So let's call it as RDS DB identifier, right? So how do I log in to the database, right? So you could do RDS AWS DB instance default. Is it default? Yeah, default dot. How do I know what it is, right? So let's go back dot. Here you have a list of all the things that can be added. So you could say either say address. That's number one. Let's see what comes in address. It only RSS. I actually want an I actually want a string which we can use to connect. I that is called as identifier. And let's see if there is any identifier prefix, right? So these are the two things. Now if you do a Terraform apply again, this is going to add two things and could give you an output. I say yes. So this is the DB address that is used to connect, right? So I just need this. Now what is happening? I don't have to go to the AWS console to get that identifier. As soon as the database is created, this will be this will be exported and I will be able to connect to the database. Right? This is much better. And anyways, the password is sensitive, so it will not be displayed out. Similarly, you can export the subnet ID, you could export the VPC, you could export the security group ID, you could export the EC2 instance, IP address, anything and everything that you want to export, like output, you could do that part over there. You just have to play around with the output.tf, right? If you don't want to keep it in output.tf, you could keep it in the main.tf. It's just that it will get added over here. So this is how you use outputs to get information so that you don't have to go inside the AWS console to check for the information. Everything is available at your fingertips using the Terraform command line. Clear? Next, what we are going to do today is do something with Route 53. So I'll say Route 53.tf. Now the first thing that I would be doing is creating a hosted zone in Route 53. So let's do that. There is documentation. I don't know what it's called. Is it, yeah, Route 53. The first thing that we need to create is a zone, right? So what am I going to create? Am I going to create a public zone or am I going to create a private zone? Obviously, I want to create a private zone, so I'll come to this block, which is actually creating a private zone for me. So this is the block that's creating a private zone. I call it, I'll leave it that as private. Here, you could call it as mm, batch number 38.com, right? Or you could call it as edu, or you could call it as tech, whatever you want. Batch number 38.tech, and the VPC in which, so if you still remember, for hosted zones, right, you need the VPC. You need to attach it to a VPC so that it can start working, right? So this is a private zone that we are creating. Again, a Terraform apply will show you what changes we can do. And if you see, it is adding stuff to this. Blah blah blah. It's creating a new Route 53 hosted zone, and this is what we are going to do, which is excellent. I don't have to do much. Um, this is creating, still creating. It should be creating, right? Now, if you want to double check, you can go to Route 53 and you would be able to see a hosted zone is available, and that hosted zone should be batch number 38.tech. Okay, and here what you can do is you could create your own records. So I could go to Route 53. I could create my own records. Very simple, right? Nothing fancy. Um, so this is the AWS record. I'll call it as DNS1. So this is the primary zone. That primary zone is actually private. Dot zone ID. The name is let's call it as demo1 dot batch number 38 dot tech, right? It's a type A record. The TTL is being kept at this. For records, what I'm going to do is I'm going to hardcode this to 10.38.0.2. Okay, this is the IP address, or this is the record that I want to create with this. If you're wondering, the zone is still being created. Why? I don't know. Let's actually see what's is anything wrong with the hosted zone? I don't think so. But the hosted zone is there. So let's actually go ahead and see. Still creating. Still creating. Okay. Host zone was created. Now I'll again do a Terraform apply to create DNS records. So this is the first record that we are creating, which is demo1 dot batch 38 dot tech, and apply got cancelled. Why? I don't know. Let's look into it. I didn't say a yes or anything. Maybe that's why it got cancelled. I'll say yes, and this will actually create a record for you. Again, nothing fancy, nothing super critical, right? It's just plain stuff, right? Just created a record. If you want, you can create a C name. If you want, you can do something else. But why I want you to do this is, let's say I want to create a DNS2 where the IP address 1, and let's say I want to create a DNS3 where the IP address 3, and so on and so forth. Let's say you have 4, 5, 6, 7, 8, 9 DNS records, and you want to create all of them. Okay, this is still gonna work, but this is the state at which we are in. Now the problem is, let's say you are going to have 3,000 odd servers on the VPC 65,000 IP set. Let's say you end up with 5,000 servers. 5,000 into 6, 7 lines of code is a really huge file to manage, right? It becomes very big, and you can't manage that huge a file. It would be something like copying this piece of code, like these are like what, 4 records. Copying this 1,000 times will give you 4,000 records. Copy pasting it, right? And this is not a very great way of doing it, because you're repeating the code. The code is becoming lengthy. It's difficult to push the code, pull the code, a lot of stuff, a lot of things happen. Now, is there a way around? Yes, there is a way around. What you could do is you could play around with something called as for loops for each. Right? There is something called as a for each loop which can be used, which you could use to play around with this stuff. So basically, what am I going to say? I'm going to say for each, right? For each. Now, is there a way around? Yes, there is a way around. What you could do is you could play around with something called as for loops for each. Right? There is something called as a for each loop which can be used, which you could use to play around with this stuff. So basically, what am I going to say? I'm going to say for each, right? For each. And if you see, there again would be some official documentation of Terraform, which would tell you how to use it, right? So if you want, you could do a map kind of thing for each to map, or if for each string or for each bucket. There's this a lot. Probably will be using this for each name and the value, name and the value, name and the value. It is going to create the thing for us. Right, so let's actually see what my previous examples was using. I have it over here. So yes, it is a for each to map, right? So it's always better to be here. So this is a map, this is a string, this is a module. For our requirement, we'll go with the top map. So to map is what I'm going to use. What am I going to map? I don't know for now, but I would say map demo1 dot batch number 38 dot x to IP address 10.0.0.1, right? I want this to be the first one, and so on. What I'll do is I'll keep on having the other ones also. If you want, you could keep this in double inverted commas. Make sure that it doesn't way around 10.0.0.2, right? Something like this. And let's see how it goes. I don't even have to provide the batch number 38 stuff, so I could just say this. because even if I just provide demo one, the rest of the part would be taken in accordingly. How did it create our record in the first place? Did it create a duplicate? No. Yeah, it just created this. But even if I just provide demo, it is going to create the record straight away for us. Now here if you see, there is a small change that I'm doing. Demo 1, I'm changing the IP address from this, which I now don't want, to 10.0.0.1. Demo 2, I want to make it as this. Demo 3, I'll make it as 10.0.0.3. Now, if you see, I intentionally kept two of the things in double inverted commas and one of them in no inverted commas. Why? Because I want to see what's the error that we will get if we are going to get an error, right? Now, the error should come in the parsing phase itself. It's not that it would come in the applying stage. If there is a syntax error, it would actually come when you do the Terraform plan in the first place itself. So it says this. It's also destroying one record. Why? Because this one, demo one, was pointing to this IP address, which we are now changing it to point to the other IP address. So this one is being destroyed, and we would be creating the other one, which is this. And if you see, we are getting a very nice error saying that it already exists. Okay. Now let's actually go ahead and see the number of DNS records that it already has. It doesn't have any DNS records. So let's do a Terraform apply again and then see if it works or doesn't. Or maybe there is something which is wrong. Let's see. Asking me to create three things. Creating demo 1, demo 2, and demo 3. Is it again going to throw an error or not? No, demo 1 has been created. But demo 1 has been created with 10.38.02. Right? So, how do you get rid of this? You could delete the record over here, but let's fix it over here itself. So, how do you get rid of it? Now, I'll tell you why we are getting this problem. The problem we are getting is because here in the older record, right, that it the name that we entered in Terraform was DNS1, and here also the name that we entered is DNS1. I can make it as DNS records, and now what I can do is I can specifically destroy this single object, and then we can remove the rest of the stuff. So let me show you how that is done. I'll show you the easiest way it is done. Just comment out this block and do a Terraform apply, and you could delete the record. And if you do a Terraform apply, so what Terraform is going to see in the remote state file, that is the TF state file that is there in the S3 bucket, this record is available, but in your configuration this is not available. So what is it going to do? It is going to delete this stuff. I'll say I don't want to delete it like this. I want to show you that there is a Terraform destroy option. I can use a Terraform destroy, but if you do this right, it is going to destroy all the resources that I have. That is the VPC, the subnet, the route tables, the RDS, the hosted zone, everything, right? So Terraform destroy is going to say that I'm going to destroy all the 16 resources, which I don't want. How do I then fix it? You could use something called as target equal to, right? You could use something called as target to actually delete the records. 1 second. So there is this formatting issue. .dns1, right? And now if you try to do this, what is going to happen is most likely it should only be targeting your single record, that is DNS, right? So it is wants to delete just one thing and one thing only. This is demo one will be destroyed. Okay, I don't have any problem. Now that the thing is being destroyed or will be destroyed, what you can do is you could get rid of this block altogether, and then you could play around with this block. So demo 3, and I'll give 10.0.0.0.0. Right. I'll put it like this. Now I don't want to destroy, I want to create the stuff. So I will do something called as Terraform apply, and that should apply the changes. So again, this one is very handy. So if you want to just delete one resource at a time, this is what is going to help you out. Right. Let's see what is it doing. It says it wants to add two things, whereas it should be adding three things. So let's actually see what's happening. So demo 1 and demo 3 are being created. I guess demo 2 was already created some time back. That's in the last run. Demo 2 might have been already created. Now, okay. Response record ID invalid character record said demo 1 type A, but it already exists. Wow. So why is it not okay? So why is it not deleting it? We just added the for each block, but if you see, I have not changed this block yet, right? So what would come over here? What would come over here is for dot each, and what would come here is for each value. This is how the documentation read. So if you want, you could go back to the documentation. So that is each dot key and each dot value is what we need to use. So this is each dot key would be used here, and I need each dot value to be used over here. Now it already is in double inverted comma, so I don't need a second double inverted comma. I'll just call it as each dot value. So this is the reason why it was failing left, right, and center, right? And I need to close this curly braces with the one that is there on the top. Now you see that all of this code is not in a proper format, right? So what you can do is you can use something called as FMT, that is Terraform format. What this is going to do is realign the code in a proper way that it is easy for us to read, right? So now you see that the spacing and everything has been formatted correctly. Now let's try to run the code and then see what is happening. Terraform apply. Obviously, it is going to give me again an error saying that okay, no, it already exists. But let's see how this functions. So this says it wants to delete one thing and add two things. I'm more than happy for it to delete one thing and create the other two things. The only thing that we want is it should complete without any errors. Still creating is what it says. Creating completed. Creation completed after 19 seconds. Okay. So deletion of the first record also completed. That is great. But I don't see demo 2. So let's actually see what happened there. Still creating the first record, which is bad. I don't know why it has to take that much time to create a record. Okay, demo 1, demo 2 there. Why is demo 2 not coming? So let's actually see. Yeah, demo 2 is not coming because here again I have a typo wherein I've just given the same thing twice, right? So I again will do a change, correcting myself, and this should now actually create proper stuff. So it's going to change one thing, it's not going to destroy anything. So it is going to change demo one's IP address from this to this, and it is going to create an new record for this. So make sure that you're not making all of these silly small mistakes while creating it. Be extremely careful when you're doing it. So with this, what we know is even if you just provide the key without any single quotes, it should still work. But let's say your key has a dot or a hyphen or a special character, then it's much better to provide it in double inverted commas and stuff like that. Right. Now, so this is how you would write your for loops in this part. Okay. Now this brings us to the very end of Terraform, right? In the next class, which is tomorrow, we would be dealing with modules in Terraform. So I would be creating modules, and then we will try to see how you can use those modules to write your own code, right? So this is something that we'll do tomorrow. This is where we will stop for now.